Welcome back to the channel. In today's video, we're diving into a super important topic in math, powers, and indices. Whether you are just getting started or need a quick refresher, this lesson will help you understanding the rules, applying them confidently, and solving problems. Let's start. Powers, you're supposed to know what is the base, exponents, or index, and the coefficient. Example, if I have 3x to the power of 5, you're supposed to know that 3 is the coefficient, x is the base, and 5 is the exponent. Sometimes we call it index, and sometimes we call it also power. Now, let's move on to zero index concept. In case we have in the place or in case we have index of 0 or exponent of 0, simply we'll turn everything into 1 with taking care of the sign. Just remember that 0 is a hero, will turn all into 1. Let's start. First of all, we're supposed to know that here in our case x cannot be 0 because we can't raise 0 by another 0, it's undefined. Let's take couple of examples to understand the concept of zero power. 3 to the power of 0, x to the power of 0, and 3x to the power of 0. Also, we're going to take some negatives here. Of course, 3 to the power of 0, as we agreed that everything raised to power of 0 is 1, x to the power of 0 is 1. Also, 3x to the power of 0, also 1. Here in this question, part D, minus 2, all of it to the power of 0, because 0 above everything, so we're going to say it's 1. Now here, minus 3 to the power of 0, 0 is above 3 only, we still have negative, which is outside, so we're going to say that negative will remain, and 3 to the power of 0 is 1, so the answer will be negative 1. Here is the same case, negative is outside, 0 is above 5 only, so we're going to end up with negative 1. We are done with zero index. Let's move on to the next concept, negative index. In case we have x to the power of minus 3, we can write it as 1 over x to the power of 3, such that x is different than 0. This is a condition. The power of negative, we can put it downside, make it positive, or if it was downside, we can flip it, put it as negative. Example to understand more. Here they are asking us to write each as a positive index. Let's do them. 3 to the power of minus 2. As we agreed, it's going to be 1 over 3 to the power of 2, because when we switch it or flip it, we're going to switch the sign. In part B, 5 to the power of negative 4 is 1 over 5 to the power of 4. Now x to the power of minus 3 is 1 over x to the power of 3. X to the power of minus 5 over y to the power of minus 7 equals y to the power 7 over x to the power of 5. Here, because we have negative upside, but the index above 7 is positive, so we're going to keep the 7 to the power of 2 in its place. Because our aim is to write in positive index. So we're going to bring down 8 caret of minus 2 becomes 8 power of 2, so now downside, I have both of them 8 caret of 2. And 7 caret of 3, and upside we're going to write just 1. So as you can see, the answer is indeed written as positive index. In part F, we bring m to the power of negative 5 upside and we write it in positive index, while x to the power of 3 we keep it up. So the final answer will be x to the power of 3 times m to the power of 5. Let's move on to the next concept. Here, a reciprocal of a number, you're supposed to know how to get a reciprocal. Simply, if I have n to the power of 2, the reciprocal of it is 1 over n to the power of 2. Means we flip it without changing the sign. Also, you're supposed to know that the number and its reciprocal are not equal. So you can see that we put an arrow, not an equal sign. Usually, we use the reciprocal in order canceling the coefficient, like if you are solving an equation, let's say 3x equals 5, in order canceling the 3 beside x, we multiply by 1 over 3, in order solving the equation and getting the value of 1x. So that the mathematician create the reciprocal. Let's find the reciprocal of each number. The reciprocal of 2 is 1 over 2 because actually it was 2 over 1, just flip, it will be 1 over 2 without changing the sign. We never touch the sign when we find the reciprocal. Again, we never touch the sign when we find the reciprocals. Let me put the arrows here. So in part A, 2, which is 2 over 1, just flip. So the answer here will be 1 over 2. The reciprocal of 3 over 5 is 5 over 3. Here 17 over 5, so it's easy, just flip. Now let's take complex cases. 3 to the power of minus 2, the answer will be 1 over 3 to the power of negative 2 as a reciprocal, and because we took the negative index, we know that in case negative we can flip the side, so I flip the side 3 to the power of 2. These are equal, but these are not equal. Take care of this point. Now x caret of 3 becomes 1 over x caret of 3. As we agreed, we flip. Here also, flip everything. We're going to end up with y to the power of 7 over 3. That's all for the reciprocal concept. Now let's move on to the next concept. But before I move on, I would like to check if you are enjoying the video so far. Don't forget to like, subscribe, and follow the channel for more easy to understand math lessons every week. Let's continue multiplying powers. In order multiplying powers having the same bases, simply we add the exponents. So the rule says that if I have x to the power of m times x to the power of n, simply we add the powers, we add the exponents. Direct example, x to the power of 5 times x to the power of 7. We're going to end up with x to the power of 5 plus 7 or 12. Now let's take some advanced examples to understand more and more. Here, we have easy, medium, and high-level questions. Okay, here in Part A, we have 2 to the power of 3 times 2 to the power of 5. We are going to just adding the exponents. 3 to the power of 7 times 3 to the power of minus 2. Of course, we cannot use the calculator, so you are supposed to know how to deal with negative numbers. If you don't know how to deal with negative numbers, you cannot pass this lesson. So please revise how to deal with negative numbers before you start. Now we're going to add these two. 7 plus 2 means 7 to 2, which is equal to 5. So we're going to end up with 3 to the power of 5. X to the power of negative 5 times x to the power of 4, just add them up. 5 plus 4, you're going to end up with negative 1. So the answer will be x to the power of negative 1. Very good. Let's move on to part D. X to the power of minus 5 times x to the power of minus 6. We're going to end up with x to the power of, adding them up, we're going to end up with negative 11. Now, let's make a discussion about part E and part F. Here, we see clearly that we have coefficients before the power. So, what we do in this case, simply we're going to multiply the coefficients. So here 3 times 4 is 12, x to the power of 7, because we know that in multiplying we add the exponents. So in multiplying we add the exponents, but we multiply the coefficients. The answer is 12x to the power of 7. In part F, we do the same. We're going to multiply the coefficients, so we're going to end up with 8m to the power of minus 3 plus minus 7, or minus 10. So the answer is 8m to the power of negative 10. Very good. Now let's move on to dividing powers having the same base. Simply, the dividing powers rule says that in case I have the same bases and I want to simplify, we follow the rule by subtracting the exponents, so we minus them. So the final result will be x to the power of m minus n. Let's take a direct question here. X to the power of 12 divide by x to the power of 3. So we minus the exponents. 12 minus 3. We're going to end up with x to the power of 9. Very good. Now let's take some examples to understand different level of questions. We're going to simplify all of them without calculator. So 2 to the power 3 divided by 2 to the power of 8. We just minus the powers or minus the exponents. 2 to the power of 3 minus 8. We're going to end up with 2 to the power of minus 5. Yeah. Very good. Now 7 to the power of 3 over 7 to the power of 5. We're going to end up with 7 minus 3, 5, right? Because we have double minus, we're going to end up with plus, so minus 3 plus 5 or 2. Now this one is the same. 8 to 2, we're going to end up with minus 10. Here also the same, because we have same bases, we're going to minus them. 3, 7 end up 3 plus 7 or 10. Part E. I'm just telling you that division and fraction are the same. Means we minus the exponents. M to the power 7 divided by m to the power of 8. Means 7 minus 8, or m to the power of minus 1. Very good. Part F, because we have coefficients, you already know it, just divide the coefficients and minus the exponents. So 18 over 3 is 6, and 2 to minus 6 is 8. We're going to end up with 6x to the power of 8. Very good. Let's move on. Now we are going to move the concept of power to another power or further powers. The rule says that if I have x to the power of n, all of it raised to the power of m, the result will be x to the power of n times m. Example. Simplify the following powers. X to the power of 2, all of it power of 3, we're going to end up with x to the power of 6 because we multiply the exponents. Now, let's solve these questions together. These questions are confusing for students. So, Please, focus to understand. Part A, 7 to the power of 3, all power of 5. Simply we're going to multiply the exponents so we end up with 15. Too easy. Part B is the same. X to the power of 2 times negative 4, we're going to end up with negative 8, so x to the power of negative 8. Part C is the same. We're going to multiply negative 2 by negative 11 to get 6 to the power of 22. Now let's move on to part D. Simply when you see that you have a coefficient before the variable, what you have to do is to turn the coefficient into a power of 1. Means add 1 here, means 2 power of 1. So I'm going to write it 2 to the power of 1. Now what you are going to do is to distribute here by multiplying by for all components or both powers clear. We're going to multiply both powers here. We're going to end up with 2 to the power of 4 because farther powers we multiply and x the power of 12. You can write 2 to the power of 4 as 16 if you want. Now let's move on to part E, which is similar to part D. We're going to turn 7 into 7 to a power of 1. Very good. Now we're going to distribute the 2 among both of them. We're going to multiply because in farther powers we multiply, thus we're going to end up with 7 to the power of 2. X to the power of negative 10. Very good. Now, let's move on to a more complex case. We see clearly that we have here 2 bases or 2 powers and a coefficient. So what do we do in this case? The same way, we turn the coefficient into a 3 to the power of 1. Very good. Now, distribute the 4 among all of them, so we're going to multiply 1 by 4, 2 by 4, and 3 by 4. We're going to end up with 3 to the power of 4, x to the power of 8, y to the power of 12. Very good. Now, let's do some practice. Mixed questions. Higher level questions. Simplify each, of course, without calculator. Now, this one a little bit confusing for students because we have here to combine 2 concepts. Multiplying concept and dividing concept. In the first place, what we have to do here is to simplify the upper side or the numerator 2 times 3 because we have coefficients and to add the exponents. So we're going to multiply the coefficients 2 times 3 is 6x. We're going to add these 8 plus minus 2 or 8 to 2. We're going to end up with 6x to the power of 6 over 5x to the power of 7. Now 6 over 5, we can't simplify them more. So we're going to keep them x to the power of 6 over x to the power of 7 minus the exponent 6 to 7 is negative 1. So we're going to end up with 6x to the power of minus 1 over 5. I hope that you got the question. Part B. We see clearly that we have coefficients, so we're going to start by multiplying 6 times 8, which is 48. We're going to add the exponents upside. We're going to end up with 48m to the power of 2 over 2m to the power of negative 4. Simplify 2 minus minus 4 is equal to 6 to get 24m to the power of 6. Very good. Thank you so much for paying attention. See you in the next video.